equilibrium chapter, ionic equilibrium. In this case, they have given, we have 20 ml of 0.2 molar HA. Weak monoprotic acid they have given, it is titrated with 10 ml of 0.2 molar NaOH solution. pH of the solution at this temperature we have to find out. They have given the pK of the weak acid is 4.76. So first of all, I have to see that is this a case in which this complete weak acid will get titrated with NaOH, or will get complete, I can say it will go to the equivalence point, or this is not getting the complete titrated. So if the reaction is not getting completed, so reaction or the process or the solution will behave as buffer. Or if the this complete HA will get titrate, so at the equivalence point we have to apply some other concept. So I have to see that what kind of mixture it will be. So let's do the reaction. So this is saying we have HA. So this HA is reacting with NaOH, sodium hydroxide. So when this reaction occurs, it will give NaA plus H2O. So the volume of HA was given 20 ml, and the concentration of HA they have given is 0.2 molar. It is a monoprotic acid, so single type of single, we can say n factor of HA will be 1. NaOH they have given volume is equal to 10 ml and its concentration is also 0.2 molar. So I can say the amount of HA is 2 millimoles. Just multiply volume with molarity, you will find the moles of the HA. Since volume is given in ml, so I have to say these are millimoles. So millimoles of NaOH will be equal to 2. The millimoles of HA are 4 and the millimoles of NaOH are 2. It is 2 millimole. So the NaOH is the limiting reagent. NaOH we have in smaller quantity. So out of 4 millimoles of HA, 2 millimoles of HA will react with NaOH completely. So from here 2 millimoles will react. 2 millimoles will react with NaOH. And as per this stoichiometry, I can see that if 1 mole of NaOH react with with HA, so it will give 1 mole of sodium, the salt of Na. So 2 millimoles of HA will give 2 millimoles of NaA. So now in this case we have some quantity of sodium salt and some quantity of the weak acid. So this is a case we can call this as a buffer. This is a case of buffer. And what kind of buffer it is? It is the acidic kind of buffer. So I can directly apply the equation that pH is equal to pKa plus log of concentration of salt divided by the concentration of remaining acid. This we can say. So as per the question, they have given pKa is equal to 4.76 plus log, how much concentration of salt they have given. So what we have find out, the concentration of salt will be the moles of NaA divided by the total volume. So total volume will be 2 by 30. So concentration of salt is 2 by 30 divided by the concentration of acid. So out of 4 millimoles, 2 millimoles has reacted. So from here I can find out the amount of this acid is remaining is 2 millimole. So again the acid amount is also 2 millimole and the total volume after mixing will be 30. So for both of them the volume will be equal to 30 and I can see the concentration of salt and the acid is equal. So this will be equal to log 1 and log 1 is equal to 0. This value, this log 1 will be equal to 0. So I can say that pH will be equal to pK. That is equal to 4.76. So in this case the pH of the solution we will find equal to 4.76. So this should be the answer. Okay.